Jai Shri Gurudev. Good morning to everyone, students. Welcome to chemistry class. In this class we are going to study dual nature of electromagnetic radiations. In the previous class we have studied how the electromagnetic radiations, it means light radiations, behaves both wave nature as well as particle nature. That both the natures we call dual nature. Okay, here the phenomena such as interference, diffraction, polarization, those phenomena is explained by wave nature of electromagnetic radiations. It means wave nature of light radiations which are come from sun. So similarly, the phenomena such as photoelectric effect, black body radiations, and atomic spectra of an atoms, those are explained by particle nature of electromagnetic radiations. It means some phenomena is explained by wave nature and some other phenomena are explained by particle nature. Thus, the light radiation is having both wave nature and particle nature. That is called dual nature of electromagnetic radiations. Okay, I hope you understanding. Now the light radiations are electromagnetic radiations behaves both wave nature as well as particle nature. Based on that nature, the light radiations, when we are passing to the certain atoms into the atoms are taken into the evacuated chamber, and when passing these electromagnetic radiations, we can observe the number of lines those which are present in an atom. That helps to understand the structure of an atom. By that concept, these electromagnetic radiations can be classified to two types of spectra based on their absorption or emission. That is called atomic spectra. The next concept is atomic spectra. Atomic spectra. So before going to the atomic spectra, the based on nature of emission or absorption of these electromagnetic radiations can be classified to two types of spectra, that is emission spectrum and absorption spectra. That is based on nature of emission or absorption of electromagnetic radiation, that is EMR, electromagnetic radiations, can be classified into two types of spectra. Spectra is nothing but a pattern of lines. Those we are observed by spectroscopically. Spectroscopically means it is an instrument to analyze the number of lines present in an atom. By this type, we are classified into two types. One is emission spectra, and the second one is absorption spectra. So here the word itself says, observe here the emission itself says that emission of electromagnetic radiations results to get emission spectra. Similarly, absorption of electromagnetic radiations results to get absorption spectra. Now emission spectra is defined as the spectrum of radiations which are emitted from the substance which is already having absorbed energy. Absorbed energy is called emission spectra. Now, for example, to understand the emission spectra, let's take this is the source. Let's assume this is sun. This is the source. So let's assume this is the sun, or we also called as source. It has high energy, right? So these radiations are passed through the prism through slit. Let's take this is the prism and this is slit. Through this slit, we are passing the light radiations. The light radiations we are passing through this slit on this prism. prism. This prism splits this radiation into number of ways. This is called photographic plate. And this plate, this number of lines are split into, or the light coming from the sun means source just splits into number of lines that you know, like that. This is called emission spectra. The resultant spectrum is called as emission spectrum. This is observed only the system or substance that having already absorbed energy. Here the emission spectra is nothing but the spectrum of radiations which is obtained by emitting the energy which has already having absorbed energy. ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಆಗಿರಬಹುದು, ಒಂದು ಸೋರ್ಸ್ ಆಗಿರಬಹುದು, ಅದಕ್ಕೆ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಂಡು ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಒಳಗಡೆ ಇರುವಂತಹ ಎನರ್ಜಿಯನ್ನ ಎಮಿಟ್ ಮಾಡೋದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಎಮಿಷನ್ ಸ್ಪೆಕ್ಟ್ರಾ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹಿಯರ್ ದಿ ಸನ್ ದಟ್ ಹ್ಯಾಸ್ ಇಟ್ಸ್ ಓನ್ ಎನರ್ಜಿ, ಇಟ್ ಎಮಿಟ್ ರೇಡಿಯೇಷನ್ಸ್, ರೈಟ್? ಅಂದ್ರೆ ಸೂರ್ಯನಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಥವಾ ಎನರ್ಜಿ ಅನ್ನೋದು ಬರ್ತಾನೆ ಇರುತ್ತೆ. ಆ ಎನರ್ಜಿಯನ್ನು ನಾವೇನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಒಂದು ಸ್ಲಿಟ್, ಅಂದ್ರೆ ದಿ ಸ್ಲಿಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಓನ್ಲಿ ಟು ನ್ಯಾರೋ ದಿಸ್ ಲೈಟ್ ನಾವು ಕಾನ್ಸಂಟ್ರೇಟ್ ಅಥವಾ ನ್ಯಾರೋ ಅಂದ್ರೆ ಒಂದು ನಮಗೆ ಸಣ್ಣ ರೇ ತರ ಬರೋದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಸ್ಲಿಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ. ದಟ್ ಸ್ಲಿಟ್ ರೇಡಿಯೇಷನ್ಸ್ ಇಸ್ ಫಾಲ್ ಆನ್ ದಿಸ್ prism. It splits into number of lines. Idra mele haagtave number of lines barutte. Those lines are collected on a photographic plate. This is called as emission spectra. Now again, this emission spectra can be classified into two types. One is line spectra and another is band spectra. So again, this emission spectra is classified into two types. One is continuous spectra and second one is line spectra. These are the two types of emission spectra. Now the continuous spectra is defined as, the continuous spectrum means when the light radiation, similarly when light radiation is passes through slit on falling prism, it splits into number of lines. These lines having continuation means these radiations emitted continuously without any breakage or breakup, like not particles ತರ emit ಆಗೋದಿಲ್ಲ, lines ತರ emit ಆಗ್ತಾ ಇರುತ್ತೆ. And these having range from violet to red. These radiations having the range from violet to red, that is, you know, the Vibgaya. So these colors we see in rainbow colors. So these lines having range from violet to red means UV visible region. ಅಂದ್ರೆ ultraviolet ಮತ್ತೆ visible region ಅಲ್ಲಿ ನಾವು ಈ ರೇಡಿಯೇಷನ್ಸ್ ಅನ್ನು ನೋಡಬಹುದು, UV visible region. So this type of spectrum is called continuous spectrum. Okay, and similarly now for example, for continuous spectra, the light radiations emitted from sun or the light radiations emitted from bulb. You bulb alli nodirbodu athwa glowing of candle or lamp. Those are the best example for continuous spectra. So light radiations sun inda baruttadagibodu, bulb ಅನ್ನೋದು ಉರಿತಾ ಇದ್ದಾಗ ಅಂದ್ರೆ ಗ್ಲೋ ಆಗ್ತಿದ್ದಾಗ the radiations will be emitted from the bulb. Those are the best example for this continuous spectra. And also, you know, the rainbow is formed when falling rain or rain falling ಆಗ್ತಿರುವಾಗ ನೀವು rainbow ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು at day times. That is the best example for continuous spectra. In this continuous spectra, these lines are continuous and they are miscible, means they are mixed with each other. Here the best definition for continuous spectra is when the radiations emitted from a source is passes through the slit on falling prism. It splits into number of lines which are collected on photographic plate. These lines are continuous and they are merges or mixed each other or one another. Such type of spectrum is called as a continuous spectrum, and the best example is this one, means emitting of radiations from sun or emission of radiations from bulb or glowing of lamp or candle, etc. Similarly, when the water drop is present in the surface or atmosphere and that water droplet, the sun radiations is fallen, it shows number of colors. Those are the best example for continuous spectrum. Okay, these are the examples. And similarly, take line spectra. So line spectra is nothing but the radiations are like lines, and they contain number of lines, bright lines, and there are behind there is a background black surface. So line spectrum is defined as it consists of number of bright lines with background surface is called as line spectrum. So here in the line spectrum, the light radiations are emitted continuously, and those lines is consist of number of bright lines, group of lines, number of bright lines and group of lines like that. These are the number of bright lines or group of lines. These are separated by a black background, that is like we can see number of grouped lines, that is called as line spectrum. Here best example for line spectrum, take the sodium metal. The sodium metal shows two line spectrums, means two spectrum of lines. Similarly, the hydrogen shows 5 series of spectrum line, that is line spectrum. This line spectrum is also called as atomic spectrum. This line spectra is also called as atomic spectra. Now we are going to study atomic spectra of an hydrogen atom. So here this is the emission spectra, under the continuous and line spectra. So similarly, absorption spectra. Absorption spectra is nothing but absorption of light radiation from source to any substance. For example, unheating iron, it emits radiations. Before heating, it absorbs some radiations, right? ಅಂದ್ರೆ ನಾವು ಯಾವುದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನು ಹೀಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಅಂದ್ರೆ ಕೋಲ್ಡ್ ಕಂಡೀಷನ್ ಇದ್ದಾಗ ಇಟ್ ಅಬ್ಸರ್ವ್ ಹೀಟ್ ಎನರ್ಜಿ. So that is the best example for absorption spectra. Here now in the absorption spectra, like assume the sun radiations are the white radiations which containing all the colors, right? Now such kind of radiations is passes into a mirror having green color. During that time, the mirror can absorb all the colors except green. It emits green color, right? That is the best example for absorption spectra. So it emits a green color and absorbs rest of the colors. It means all colors. So that is the example for absorption spectra. So absorption spectra is defined as the spectra which can absorb all the radiations and emit only one color, those which is same as that of the substance. Substance ಯಾವ ಕಲರ್ ಇರುತ್ತೋ ಅದೇ ಕಲರ್ ಬಿಟ್ಟು ಮಿಕ್ಕ ಎಲ್ಲನೂ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ಎಮಿಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಎಮಿಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಬೇರೆ ರಿಮೈನಿಂಗ್ ಕಲರ್ಸ್ ಎಲ್ಲ ಅಬ್ಸರ್ವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸಚ್ ಕೈಂಡ್ ಆಫ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಸ್ಪೆಕ್ಟ್ರಮ್. ಸೊ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್, ಪಾಸಿಂಗ್ ವೈಟ್ ಲೈಟ್ ಇಂಟು ದಿ green color mirror, it absorbs all the colors except green. Similarly, passing white light into the red color mirror, it absorbs all the radiations except red. So such kind of spectrums we called as absorption spectrum. So I hope you understand the concepts behind that emission spectra, continuous spectra, line spectra and absorption spectra. Now we are going to study the line spectra or atomic spectra of hydrogen atom. Line spectra or atomic spectra of hydrogen atom. So next concept is atomic spectra of hydrogen atom. So here the discharge tube is taken to understand the atomic spectra of hydrogen atom. We are taking a discharge tube. You know this discharge tube connected with a battery of high voltage, that is about 10,000 volts, and inside that there is a low pressure, and here we are taking hydrogen gas in discharge tube. Now we are passing the electric current and electromagnetic radiations. So in the discharge tube at low pressure, by taking hydrogen gas, we are supplying high voltage. These emit the radiations, means it emits the radiations. These emitted radiations is passes into the spectrophotometer. By analyzing these emitted radiations is analyzed by spectroscopically, means by using spectrometer get number of series of lights. Such results we called as a line spectrum or atomic spectrum of hydrogen atom. Line spectrum or atomic spectrum of hydrogen atom. These line spectrum consists of 5 lines, that is the line spectrum or atomic spectrum of hydrogen atom is consists of 5 lines, that is number of branches of lines. Those we write like that. These are the number of branches of lines. We can see 5 groups of lines like that. We can see 5 groups of lines when we are passing these radiations into the spectrophotometer, or by analyzing these radiations in spectrophotometer or spectroscopically. These lines we are named Lyman series, Balmer series, Patches series, Bracket series and Fund series. These series are observing only hydrogen spectrum called atomic spectrum of hydrogen atom or line spectrum of hydrogen atom, and these lines have different energies and integrals. Those we are studying in Bohr's atomic speed, Bohr's atomic model or Bohr atomic theory. Here this is called as Lyman series. For these lines, we give a name that is called Lyman series, Balmer series, and Patches series. And this is Bracket series, and this is called Fund series. That is P500, or we can pronounce Fund series. These are the 5 types of series. They are observed in hydrogen spectrum when we are passing these emitted radiations or analyzing these emitted radiations by spectroscopically. Okay, so these 5 radiations means these 5 branches of lines are in different wavelength and wavelength and also frequency. Those to calculate, the scientist Rydberg give a relation between wave number and wavelength and number of lines they have energies, that is called Rydberg equation. The Rydberg equation is that is 1 by lambda, that is equal to what? Nu bar. That is wavelength is inversely proportional to wave length, that is equal to RH, where RH is called as a Rydberg constant, and it gives the relation between number of lines, that is N1 square minus N2 square. This is the Rydberg mathematical equation used to calculate the wavelength and wave number of these line spectrum of hydrogen atom. Thus called Lyman series, Balmer series, Patches series, Bracket series and Fund series. These are called scientist names. They only observe the radiation at particular range. So here the Lyman series is seen on the range of UV light, that is ultraviolet range. You can see in this Lyman series, and this Balmer series is seen at a visible region, and these are seen in the range of higher infrared. So this is the visibility of these forms of these series of lines at particular wavelength. Okay, so remember the Lyman series is seen at only UV region, and the Balmer series is seen at visible region, and Spectra, Bracket and Fund series seen only at higher region. Now we are going to study or learn the line spectrum, these lines. So observe here, I am writing only the number of lines or group lines which are separated by dark backgrounds or patches. Such type of spectrum called what? Atomic spectrum, line spectrum. Actually this is not like that. Just for our convenience we are writing like the real spectrum with the number of energies for these series can be written now graphically. That is, this is the actual spectra. You can observe in spectrometer at different range of wavelength, that is UV light and ultraviolet or visible region. You can see in such kind of spectra for hydrogen atom. So here observe N is equal to 1, 2, 3, so on. This is number of energy levels. number of energy levels, and you know already the Rydberg equation, that is 1 by lambda is equal to mu bar, that is equal to RH, where RH is called as Rydberg constant into 1 by n1 square minus 1 by n2 square. So this is the mathematical equation given by the scientist Rydberg equation. Rydberg. So here this n1, n2 are these are the energy levels. For n1 the energy may be 0, that is equal to 0, and here E is equal to infinity. So energy P increases for the lines. Now for Lyman series, the first series, Lyman series, the n1 is equal to 1. Here this is the Lyman series. Lyman series, like the electrons are jumped from n is infinity to n1, and the radiations like that. The next energy level like that, it will be coming from all the radiations. Like here there is C, after 7 there is 8, 9, 10, like that. All radiations are jumped from higher energy to lower energy. During that time it emits radiations. Similarly, it will move from n1 is equal to n1 to n infinity, it absorbs radiation, that we get absorption spectrum. For Lyman series, n1 is equal to 1 and n2 is equal to 2, 3, so on, like that. Okay. So this is called what? Lyman series. Lyman series. Similarly, for Balmer series, the n1 is equal to 2 only. It won't go from n is equal to infinity to n is equal to 1. It will stop here only, that is n is equal to 2 stage. Similarly, the next line like that. So here the n1 is nothing but ground state and n2 is nothing but excited state. So such kind of lines you can see. These are the number of lines. This is called Balmer series. Balmer series. Similarly, for bracket series, the n1 is equal to what? 3. So this is the 3, and the n2 levels may be either 4, 5, 6, like that, so on. This is called fracture series. Fracture series. Similarly, for a bracket series, the n1 is equal to what? 4. That is 4. This is the number of photons we are seeing, like that. There is so many lines. This is called as what? Bracket series. So similarly, T5 series, the n1 is equal to what? 5. This is the fifth one. And these are the number of lines for n2. So this is called as what? Fund series. Fund series. This is the actual spectrum of a hydrogen atom when we are causing the radiations which is emitted from the hydrogen gas and analyzing in spectrophotometer. Now here for Lyman series, I write L for Lyman series, and Bowman series, bracket series, and bracket series, fracture series, and fund series. So observe L, B, P, D, P. That is the simple thing to remember. That is Lyman, Bowman, fractures, bracket, and fund series. For Lyman series, L1 is equal to, for Lyman series, I write like that, N1 and N2. For Lyman series, N1 is equal to how much? 1. For Lyman series, n1 is equal to 1 and n2 is equal to 2, 3, 4, 5, so on. We don't know how much they give us, but in the problem particularly they mentioned what is the n2. So here n2 is 2, 3, 4, so on. And similarly for Balmer series, the n1 is equal to 2 because the first line is touches only at n is equal to 2. Therefore n1 is equal to 2 and n2 is equal to, after that there is 3, 4, 5, 6, so on. So that the n2 is 3, 4, 5, so on. For what? Balmer series. Similarly for fracture series, n1 is equal to 3 and n2 is equal to 4, 5, 6, so on. Similarly for bracket series, 4, that is n1. So observe here for bracket series, this is the mark or curve, RMR radiation, it is 4, that is n is equal to 4 and 5, 6, 7, so on. Similarly for fund series, n is equal to 5 and 6, 7, 8, 9, so on. These are the negative values. By putting these values, we can calculate the wave number and wavelength by using Rydberg equation. Here the Rydberg constant value is 1.097 into 10 to the power 7 per meter. The Rydberg constant R value, that is RH Rydberg constant, its value is 1.0977 into 10 power 7 per meter. Remember, this is the Rydberg value. By putting this value in the equation, we can calculate wave number and wavelength of the given line. ಯಾವುದೇ ಲೈನ್ ಕೊಡಲಿದ್ರಲ್ಲಿ ನಾವು ಈ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ದಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂಡ್ ಆಲ್ಸೋ ದಿ atomic spectra is important for the purpose of exam. I hope you understand it.